Hello, my name is Mr. Pratt, Director of Science, and welcome to the next lesson on electricity. The previous lesson we looked at equations that we use to calculate power. Now we're going to be looking at equations that we use to calculate the energy in electrical circuits. For the lesson then, you're going to need the usual, that's a pen, paper and exercise book. You're going to need a calculator again in this lesson. Unless you're needing to watch this video on your mobile phone, then get it out of the way and avoid as many distractions as you can. Let's see what you can recall then. 1 minute, off you go. Should be just finishing off. Okay, units of power is watts, that's a capital W. Convert 230 millijoules into joules, so a millijoule is a thousandth of a joule, just like a millimetre is a thousandth of a metre. So you do 230 divided by 1,000, which gives you 0.23 joules. And the equation that links energy, power and time, power equals energy divided by time. If you've written it as energy equals power times time, that's right as well. The outcomes then, we're going to look at basically just describing the factors that affect the amount of energy that's transferred by an electrical appliance. I use the word transferred instead of used. I don't like using the word used because energy is not used up. It's just changed from one energy store to another. Second outcome, we're going to look at applying two equations and calculating electrical energy. One of the equations you've used before, the second one is a new equation. I also want to look at summarising all the equations that were used in electricity. I know that the electricity equation do cause the biggest amount of confusion. So at the end of the lesson, we're going to look at a way of trying to remember all 5 of them as well. Let's look at the link between energy and power first. So power is work done divided by time taken. We looked at that last lesson. I like to remember that 1 watt is 1 joule per second. So if an appliance is using 1 joule of energy, I've used the word use now, is transferring 1 joule of energy every second, it means it's working at a power of 1 watt. Work done and energy, you can really just replace the two words. They're both measured in joules. So power is energy over time as well, which is what we just looked at in the starter. If you've got a 60 watt bulb then, what that means is that bulb is transferring 60 joules every second. So if you had the bulb switched on for 10 seconds, it'd be doing 60 joules every second. So for 10 seconds, that would give you 600 joules that have been transferred. So another way of looking at that equation is energy equals the power times the time. That gives us then 2 factors that affect the amount of energy transferred by an appliance. So those factors are the power of the appliance and the time that it's switched on for. For example, you might have at home a 1 kilowatt kettle, so that's a 1000 watt kettle. If you had that switched on for 1 second, it'd just use 1000 joules. If you had it on for much longer, it would transfer more energy, which is why if you put too much water in a kettle and boil more than you need, you're going to end up using a lot more energy than you would have done, and your electricity bill will end up being bigger because it's been on for a longer period of time. Progress check then, using the equation that's at the top, so energy equals power times time. I'm going to give you a total of 3 minutes. Most of them are worth 2 or 3. Just be careful with the units that you're putting in. Make sure that you're putting the correct units in, and then we'll mark them afterwards and see how you've got on. Minute left. Let's see how you've got on then. It'll be interesting to see if you've got your units at the end of every answer. Don't miss them off. You've just got about 5 seconds to add them on if you've not put them in. Number 1 then. So energy equals power times time. So the power is 100 and the time is 20 seconds. So we just do 100 times 20 seconds, 2000, add your unit in joules. Give yourself 2 marks if you've got that right, 2000 joules. Number 2, we've got 1 kilowatt. I hope you've not put 1 into the equation. You should have put 1000 in. So energy equals power times time. So 1 kilowatt is 1000 watts. So that gets you 1 mark to start with. So it's 1000 watts times 10 seconds, which is 10,000 joules. If you've got 10,000 joules, that's 2 marks. If you've just put 10 joules, you've dropped a mark. Number 3, this time it's the minute that's the problem. You can't use 1 minute, you've got to convert it. So 1 minute is 60 seconds. So you do 20 watts times 60 seconds, which gives you 12,000 joules. 3 marks for that, if you've got that right. Last one. So we've got 10,000 joules every 50 seconds. So the power is the energy divided by time, because a watt is 1 joule per second, 1 joule divided by 1 second. So 1,000 joules divided by 50 seconds gives you 50 watts. 2 marks if you've got that right. Well done. On to an exam question now. We've got part A, where you've got to use that graph to work out the current when it's working at its normal brightness. So the current going through a filament bulb varies as it's switched on, and then it settles down after a very short period of time, about a tenth of a second. So you need to read the graph to get that bit. And then for part 3 there isn't a part 2, I've cut it out. Calculate the energy transferred by the 12-volt bulb when it's working at normal brightness. So you'll need to look at your answer that you've got for part 1 to help you with part 3. After about a minute, I'm going to put a little hint on just in case you're struggling with the second part. So 2 minutes. Just be careful you read the graph right for part 1. You might want to just put a ruler up against the screen to make sure you don't miss as you read across. Just going to put you a little hint on part 3 if you're struggling. So I'll put you 2 equations on. Power equals current times voltage, and energy equals power times time for part 3. Part A then. It's difficult to do this on screen, but if you're in an exam, what you'd do is you'd find the bit you're interested in, which is the flat bit on the right hand side of the graph, and you draw a line straight across. Use your ruler, don't slip, because if you go across and you read the wrong place, you're going to drop a mark there. So reading along, check the scale, so it goes from 1.5 to 2 there, so it's 1.5, 1.6, 1.7 amps. So 1 mark for 1.7 amps. Part 3, so we now know we've got 1.7 amps and we've got 12 volts, so it means that we can work out the power of the bulb, because the power is current times voltage. So power equals I times V, so current times voltage, so the power is 12 volts times the 1.7 amps that you've put in, which gives you 20.4 watts. If you know the number of watts, then you can work out the energy, because it's on for 30 seconds. So energy equals power times time. So energy is power times time. So that's 2.4 watts times the 30 seconds that it's on for, which is 612 joules. I think the 2 marks for that part 3 is mean. It's worth 3. I would expect it to be worth 3 on an exam question now. I have always remembered that energy equals ITV. I've just found that equation really easy to remember, because ITV as in the TV channel, so energy equals ITV. If you don't remember that, then you're going to have to use these 2 equations separately. What I'd like to do now is to look at all the electricity equations that we've covered so far. We've just got one left, but I'd like to go over all the others. So we've got V equals IR, that's sometimes called Ohm's law. It's quite useful if you remember it a different way round, if you remember that the resistance equals volts over amps, potential difference divided by current. So that's the first one. That's the first one that we will have covered in electricity. We've got one from last lesson. Power equals current times potential difference. Now we've got another power one that we looked at last lesson. Power equals the current squared times the resistance. This is in the energy topic, but also it's in the electricity topic. Power equals energy divided by time. Remember, 1 watt is 1 joule per second. 1 joule used every second. We've got the charge equals current times time. Q equals IT. Which leaves us with one more that we're going to cover, and then we've covered all of them. Energy equals charge times potential difference. Now, if you know what power is, so power equals current times potential difference, you could substitute that into the energy equation, and that's where the E equals QV comes from. One useful way to remember this, and it's a previous student that I've taught that's come up with this, is everyone quit vaping. That's particularly useful because the quit bit, Q equals IT, helps you with another equation. So everyone quit vaping will help you with two formula when you're remembering them. What we're going to do now, we're going to look at using E equals QV. So energy in joules equals charge in coulombs times the potential difference in volts. Everyone quit vaping. Got to remember that the Q is the charge though. Let's do a worked example. Probably a good idea if you record this in your book and then you can use it to do the examples afterwards. If you've got one, you can see how to do it. Straightforward, this one. Find the energy transferred in a circuit. So we're looking for energy. That's what we've got to calculate. If the potential difference is 4.5 volts, so V is 4.5 volts, and that causes 5 coulombs of charge to flow. We do what we always do. We write the formula down. And then underneath the formula, we put in what we know. We know that 4.5 volts is the V, and we know that 5 coulombs is the Q. So energy equals 5 times 4.5, which is 22.5, and we measure energy in joules. 22.5 joules, and that's to 3 significant figures. Right, you're on your own now. I'm only going to give you 4 minutes, and there's 8 marks there. So I probably wouldn't expect you in that amount of time to do all of them. So you've got a choice. If you know you're a higher student and you're hoping to do the higher paper, then do the grade 5 and the grade 7 question and leave the other one out. If you think you're on foundation, then just do the grade 4 and the grade 5. Alternatively, you could pause the video and do all of them. 4 minutes, off you go. Okay, halfway through your time. Don't forget your units in your answer. Just 30 seconds left. Don't forget your units.
Let's have a look at the first one then, see how you got on. First rule, write down the equation that we know. Question 1, E equals QV. This is just a straightforward substitution. There's no moving around, which is why it's only a grade 4. There's nothing particularly complicated about it. So we've written the formula down. Underneath the formula, let's just put in the values. So we don't know the energy, that's what we're trying to find. The charge is 30 coulombs. And the potential difference is 1.5 volts. So E equals 30 times 1.5. 30 times 1.5 equals 45. So the energy is 45. Got to remember the unit energy, that's joules, capital J. Underline the answer to draw the examiner's eye to it, 45 joules. If you've got 45, that's 1 mark. If you've got joules, capital J, that's 2 marks. Second one. Bit more tricky, there's a little bit of moving around for this one, but we'll follow the same rule. Write the equation down. Everyone quit vaping. We know what the energy is, 470 joules, and we know what the charge is, 100 coulombs. This time we're trying to find the potential difference to voltage. So underneath, energy 470 equals the charge 100 times V. Don't know what V is, it's 1 mark, substituting that in. So remember, you can do whatever you want, do an equation, as long as you do it to both sides. So if I divide that side by 100, that's good, because 100 divided by 100 is 1, so I've just got V equals now on that side, but I've got to remember to divide that side by 100. So V equals 470 divided by 100. 470, don't need a calculator, divided by 100 is 4.7. So the potential difference is 4.7. Remember the units, potential difference is volts. 4.7 volts. Underline your answer to draw the examiner's eye to it. Last one, bit trickier. Same rule though. Everybody quit vaping. Put in what you know. Well, we know V, and we know the energy, 45 point, oh careful, that's 45.5 kilojoules. So 45.5 kilojoules is 45.5 times 1000, because kilojoules is 1000 joules. So that's 45,500 joules. That's 1 mark if you've done that. So let's substitute in 45,500 equals the charge that we're trying to find. We don't know, so let's just leave Q in there, times the potential difference, times 230. Remember, you can do what you like to an equation as long as you do it to both sides. So if I divide that side by 230, 230 divided by 230 is 1, so I've got Q equals, but I've got to remember to do the same on that side. So the charge is 45,500 divided by 230. 45,500, check that you've put the right number of noughts in, divided by 230 equals 1, so Q equals 197.8260. I'll put all of that down for now, but it does want the answer to 4 significant figures. So 4 significant figures is Q equals 197.8, 1, 2, 3, 4. That one is less than 5, so it's just 197.8, 197.8, and it's coulombs. So there's 1 mark for your conversion there, 1 mark for coulombs, 1 mark for significant figures, 4 of them, and 1 mark for getting the answer, 197.8. So if you've rounded it to 3 significant figures and you put 198, you just drop 1 mark. So remember that one was out of 4, and I forgot to say question 2 was out of 2 marks as well.
Next exam question then. This time we're using E equals QV. Now this, probably on a foundation paper, it's given you the formula on. It says use the equation, and sometimes they do. And it wants the answer of the energy transferred in kilojoules and not joules. So 2 minutes, off you go. Just 30 seconds. Just make sure you've not put joules down instead of kilojoules, because that's 1 mark, that changing it into kilojoules at the end. Right, there's the mark scheme. So energy equals charge flow times potential difference. So the energy is 15,000 coulombs times 36 volts, which gives you 540,000. If you've got 540,000 as your answer, you'll pick up 2. The third mark is for putting it in kilojoules. So 540,000 is 540 kilojoules, because kilojoule means 1,000. Next bit of the question, going to give you 2 minutes. Just coming up to halfway through your time. Be careful with that 20 minutes. You can't put 20 minutes into the formula. Should be just finishing off then. Make sure you've got the right scooter when you've done your calculation, scooter B. Right, there's the mark scheme. The equation that links energy transferred power and time, so energy equals power times time. If you've used the right symbols, E equals PT, that's absolutely fine. If you've put power equals energy divided by time, that's perfectly fine. Now we need to use that formula. So calculate the energy transferred by the motor in 20 minutes. First thing that you've got to do is to convert that 20 minutes into seconds, otherwise you've just dropped yourself a mark. So 20 minutes, there's 60 seconds in a minute, so it's 20 times 60 gives you the number of seconds, which is 1,200. And it's got a power, scooter B's got a power of 700. So it's 1,200 times 700 gives you 840,000 joules. If you've put kJ, kilojoules, and you've put 840, that's fine as well, but make sure you put kilojoules at the end of it. Well done if you've got that.
Okay, so I'm going to take you through a little technique for memorising your electricity equations. Now these are some of the physics equations that you need to learn for paper 1, both triple and combined science. Here goes. So there is a very important reason for learning your equation. So V equals I times R, very important reason. It gives you power in the exams. Now write I again underneath the first I that you wrote. So you line up your I's and then you carry over your V. Then you P again because you've had too much to drink. You've had too much water to drink. And then, can you see here where you wrote your 2 I's? So I times I is I squared. So you can write I squared underneath your 2 lined up I's. Now if someone were to say I to you, so I squared is I. If someone said I to you, they would most likely be a pirate. And the other thing that pirates say is R. So P equals I squared, or I, is pirates say I. And then a little bit of friendly health advice. Everybody quit vaping. And then you can write quit vertically here. So Q equals I times T. And then don't forget about your pet at the end, because that would just be really sad. You couldn't go on holiday and forget about your pet. They'd be very upset. So you cannot forget about your pet at the end. Now, the only thing to remember is that this last equation, pet, is the only one that's divided. All the others that we've written have been multiplied. So let's try that again. There is a very important reason for learning your equations. It gives you power in the exams. And then you line up your eyes, because your eyes are lined up, and you carry over your V. And then you pee again, because you've had too much to drink, and pirates say, I, R. And then some friendly health advice. Everybody quit vaping, and write quit vertically. Q equals I times T. And then at the end, don't forget about your pet. And there you have it, all of your electricity equations for Physics Paper 1. Now what you need to do is re-listen to parts of this video, write them out yourselves, and in this format, and write them out several times until they stick, which they definitely will.
Right, electricity units quiz. Gonna try and get you to do this quite quick. So all you've got to do is to add the correct symbols for the units that we should use for each measurement. And we've got 8 to do, so I want you to do it fairly quick. You should be able to do it straight away. Let's see how many you can get out of 8. Ready, steady, start the timer, go. You should be done. You ready? First one, joules, capital J. If you put a little j, you're only having half marks. Power, watts, capital W. Both surnames. The ones that are surnames are always capital letters. Number 3, charge is in coulombs, capital C. 4, potential difference, volts. Current, 5 amps. So they're all named after someone's surname so far. 6, resistance is in ohms. That's got that weird horseshoe symbol. It's the Greek letter omega. Time is seconds. That's not capital letter, it's a small s. Work done. I bet some of you are confused thinking, I don't know what that is. It's exactly the same as energy. It's a different way of thinking about energy transfer. So number 8 is joules as well. If you've got any more than 5 on that, well done. That's a great effort. Right, I'm just going to leave you now with a summary. So I've got on the left hand side the different symbols, what they mean and what we measure them in. We've got the 5 equations that we've used at the top that Mrs. McGee showed us how to memorise, so that's something you could try after the lesson. And at the bottom, if you didn't write it down at the time, I've got a worked example of using E equals QV. Pause the video if you need to make some more notes. Well done, absolutely fantastic. Just got a few more lessons to go on electricity. I'll see you next time.